Hello students, and welcome you all again to this video lecture series on chapter mechanical testing of metals. Up till now in this chapter we have seen the tensile testing, then we have seen the impact test. Under that we have seen two types of impact test, Charpy and Izod impact test. Then we have seen the hardness testing. Under that we have seen again the three types of hardness testing, that is Brinell hardness testing, Rockwell hardness testing and Vickers hardness testing. After that, the last few tests in that destructive testing we are going to see in this week. And that first, that is a fatigue test, and after that second video will be there, which is on the creep test. After that, destructive testing will be covered, and after these two videos we will start the non-destructive testing methods. So for today's lecture we will see now the fatigue test. So what is a fatigue? In the material science, the fatigue is the weakening of a material caused by the cyclic loading that results in progressive and localized structural damage and growth of the cracks. So now the fatigue failure is nothing but the failure of the material due to application of cyclic load, and which progressively causes the damage or growth of the crack in the specimen. Now whenever you will consider one example, small example of a metallic wire. So if you want to break that metallic wire, what you will do, you will not apply the tensile load or any compressive load on that wire. You just bend and unbend that wire. That is nothing but you are applying cyclic load, continuously compression and tensile load on that wire, so that it will break immediately or within short effort, very short effort. So that is nothing but a fatigue load or a cyclic load that you are applying. Due to that, the failure of the material will occur, that is called as a fatigue failure. Now for that purpose you are applying continuously cyclic load. Here one cycle for that load is shown. You are applying the tensile load as well as compression load in cyclic manner. Similar cycles will be further there on that span. So with the help of this fatigue test, actually we are finding the endurance limit below which the number of cycles or number of the cyclic load that the material can handle will be more. So for finding that endurance limit, we need to carry out this fatigue test. So already we have seen fatigue is due to the repeated loading and unloading. When the material is subjected to force acting in different direction at different times, it can cause cracking. In time, this causes the material to fail at the load that is much less than its tensile strength. This is the fatigue failure. The vibration, for the example, is a serious cause of this fatigue failure. Yes, vibration is also a major cause of that fatigue failure. In day-to-day application, if you consider the application of any kind of motor, and at the end of that motor one application will be connected through the shaft. So whenever there will be misalignment in that shaft and motor bearing, so there will be vibrations created, and due to these vibrations cyclic loads will be there on that shaft, and due to that there will be fatigue failure of that shaft. So the vibration is a major cause of that fatigue failure. So fatigue can be prevented with the good design practice, so that a smooth surface finish reduces the chance of surface cracking. So whatever the previously surface defects are there, at that surface defect, due to vibration and due to misalignment and due to other factors and due to cyclic load, fatigue failure will occur. So if there is a smooth surface finish and good or less cracks over the surface, then there is a less chance of surface cracking due to fatigue. Sharp corners should be avoided to avoid the fatigue failure. Corrosion should be avoided, at this can cause the fatigue cracks also. So corrosion should be avoided. So these things you can do for the avoiding fatigue failure. But in fatigue test, what actually we are doing, So R.R. Murray's test is used for carrying out this fatigue test. So what he has done, he has used the one shaft or one specimen mounted in between the two bearings. In this diagram we can actually see, so one specimen is there exactly at the center, which is mounted in between the two bearings. Those bearings we have called it as a load bearings, because we are applying some amount of load W over these two bearings, so that on each bearing, on each load bearing, there will be W by 2 load acting in downward direction now for initial stage. So after these load bearings, there are two main bearings in which those central shaft will be mounted. Main bearing, after main bearing there is a connection of that shaft from that main bearing to the motor with the help of flexible coupling, so that whenever motor will rotate, that rotations will be transferred through the flexible coupling to the shaft inside the main bearing, and then from that rotation will be transferred to load bearing, and through the load bearing it will be transferred to specimen. Now W by 2 reaction forces will be there on the main bearing, and W by 2 forces will be there again in downward direction acting on the load bearing. So whenever we have rotated this shaft or rotated the motor, then the specimen will also start to rotate. But due to some amount of misalignment, there will be the fluctuation of that shaft, and we have applied also W load, so that W by 2 load will be acting on the two load bearings. Due to rotation of the shaft, that W by 2 load will be acting on the shaft just like a cyclic load. That means it will be acted, the shaft will be moving in upward direction as well as in downward direction as shown in that corner figure. So due to that motion of shaft, whenever shaft is moving in upward direction, then the downward surface of that shaft will be under compression and upward surface will be under tension. Whenever that shaft is moving in downward direction, totally downward direction, at that position downward surface of that shaft will be under tension and upward surface of that shaft will be under compression. So the surfaces, two surfaces of that shaft will be continuously going under compression and tension, compression and tension. That means a cyclic load will be acted on that shaft, just like a cycle shown in the left hand side here. So due to that cyclic load, after certain rotations, that means after completing certain cycles, there will be breaking or there will be generation of crack, and ultimately those crack will fail the specimen or break the specimen. So in applications also, whenever we are using that material in applications, so at that time also there will be application of certain cyclic loads and specimen, and we need to calculate at what cyclic loads and at what and after what rotations that material will get fail. So that judgment is very much necessary. For that purpose we are doing the fatigue testing. So after fatigue test, actually we can draw the stress versus number of cycle diagram. Stress versus number of cycle diagram. That means suppose we have applied certain load, that load will create a stress, or it will be in the form of stress acting on the specimen. So if that stress is up to yield strength, suppose, or ultimate tensile strength, suppose ultimate tensile strength, at that point that material will immediately fail without any rotation. So at higher stress, the number of cycles will be very few. That means consider it as a 0. As stress is decreased, the number of cycles will be increased. So the graph generated for the ferrous material, upward graph you can observe. So that graph generated will be decreasing like this, or with respect to maximum stress decreasing, the number of cycles will go on increasing, So After certain limit of that stress, number of cycles will not change, they will remain constant. That upward graph you can observe after certain stress, the graph has remained horizontally straight only. That means below that stress level there will be no change in the number of cycles. That means number of cycles are remaining infinite. So always we have to apply the stress, that means cyclic load on the specimen or component under application below that limit, so that the application will do the number of cycles infinite, that failure will not occur. So that limit or that point is called as a endurance limit or endurance point. That limit is called as a endurance limit. So below that endurance limit, below that maximum stress, there will not be any chance of breaking of the specimen by fatigue. So this is very much important in the design purpose. In machine design subject also you will study that endurance limit, and this is for the cyclic loading. Exactly sinusoidal wave is there, but if it is a random loading or if it is having different kind of cyclic load acting on the specimen, then for finding the endurance limit there may be different methods are applied. So those methods will study in the machine design, not necessary to here. Here you just remember the endurance limit. SN curve is very important in case of fatigue test, and we are finding this SN curve only by using this fatigue test. So this is regarding fatigue and fatigue test. Thank you all.